Hello, in this video we're going to apply our primary trig ratios to a word problem. So we want to find the length of x, then the length of y to the nearest tenth of a meter. So now this problem is actually simplified quite a bit because they tell you the order to find the values. We want to find x, and then we use x to find y. But it's really important for a second here to imagine they didn't tell you the order to find these. What is the clue that allows you to know that x needs to be the first thing that you have to calculate? What it is the fact that, notice here, if we name these, let's name these just for the sake of our discussion. See, in triangle ABC, I have both an angle and a length. So if I have an angle and a length, and I know that it is a 90-degree triangle, and we can rationalize that there, I can solve every side and every angle. However, triangle BCD, I only have an angle, meaning that I can't calculate any other piece of information until I know at least one length. So that is the clue that gives away that we must solve x before we solve y. The fact that triangle ABC has one length with it. Okay, so if I take this triangle, I'm talking relative to the angle right here. And so now I know that x is going to be the opposite and 10 will be the adjacent. So if I use the opposite and the adjacent, I use the tan ratio. So tan of 35 degrees, don't forget that degree symbol, is equal to the opposite, which is x, over the adjacent, which is 10. So therefore, x is equal to 10 tan 35 degrees. So x is approximately equal to 10 times tan of 35 is approximately equal to 7.0. Okay, so now that I know that, I will use my value of x to solve for y. So now, if I talk in terms of 48, we know x is the opposite and y is the adjacent. So therefore, we can say tan of 48 degrees is equal to the opposite, which is x over y. And now I substitute an x. Now here's a little interesting point here. Now, in our case, x is approximately 7.0, so it's not as big of an issue. But if I was really interested in accuracy here, what I would actually do is I wouldn't substitute in 7.0. I would actually substitute in the 10 tan 35 degrees, and then use this to calculate y, because in doing so, 10 times tan of 35 degrees is going to maintain my accuracy in the question. So we'll do some rearrangement, and we get so y tan 48 degrees, a little more space here, is equal to 10 tan 35 degrees. We'll divide both sides by tan 48. So y is equal to 10 tan of 35 degrees divided by tan of 48 degrees. It's a good moment to check to make sure you're putting the degrees symbol on. So therefore, I'm going to plug this in my calculator, and I'll get y is approximately equal to, and again, one step here in your calculator, 10 times tan of 35 degrees divided by tan of 48 degrees. And I hit my equal sign, and I get y is approximately 6.3. And I get 6.3, and whatever the units are, meters. And I hope that video helped. Have a great day.